In section 5.5, Algebra 2, kids, we want to talk about quadratic equations. Let's start out with a basic fact. If you knew that two things, A and B, multiplied together to give you 0, the question I have for you is, what do you know about A or B? If their product is 0, then either A is equal to 0 or B is equal to 0. I guess the possibility exists that they both could be equal to 0. But one of them has to be 0, because that's the only way we can get an overall product of 0. Now I need you to know this fact, because when we get into the next several questions, it will be plainly obvious that we need to understand that idea. So suppose I'm dealing with an equation. It's a quadratic equation because it's got an equal sign, and we're solving for x by factoring. Okay, so this is there's no GCF involved, so I don't pull out a GCF, and I can clearly see that this would be x times x, and if I need factors of 5 that add up to 7, then that would have to be a 5 and a 2. Now, I've done the factoring, and if you just want to double check, you've got x squared, you've got 2x and 5x, which add up to 7x, and 2 times 5 is 10. So we've double checked it. Either x plus 2 is equal to 0 or x plus 5 is equal to 0. One of those two sets of parentheses has to be equal to 0. That's the only way that the product of two things can be equal to 0. So, it's either this one or this one. I am not saying that x has to be 0. Please don't misunderstand that. X plus 2 is equal to 0 or x plus 5 is equal to 0. One of those parentheses. Now, if this one is true, then x would have to be equal to -2. But if this one was true, x would have to be -5. So here are the two solutions to the equation, the two values which would make this statement true. Now, I want to relate this idea to a graph of a parabola, right? I hope you understand that x squared plus 7x plus 10 could be a parabola. Now it's going to have to look a little different, and I'll show you here in a minute how we would write that. And we're going to end up using 0. Now let's take a look at this equation. So here's y equals 7x squared, or x squared plus 7x plus 10. So now it's a parabola, right? It's got an independent variable x and a dependent variable y. Now, when you put 0 in here for y, you are finding the x-intercepts. In fact, we will call those, we will have a term for that, we will call those the zeros of the function. Alright? So you're going to hear this term, the zeros of the function, and that is a reference to the x-intercepts. Now I used a program and I graphed this particular equation. Okay? Here is this parabola, y equals x squared plus 7x plus 10. And I want you to notice something. What are the x-intercepts? Where does it cross the x-axis? Well, it crosses here at -2, and it crosses here at -5. So at -2 and at -5, those are the x-intercepts of the graph. Well, that's exactly what we solved for just a few seconds ago. So when you are solving these equations, right, back here, when we're solving these equations and finding out x is -2 and x is -5, I want you to keep in mind that that's like finding an x-intercept of a graph for this equation. So there's a connection that you should be making in your mind between the idea of factoring and an x-intercept or a 0. So when we factored this and got x plus 5 and x plus 2, we should be able to locate the zeros of the function where it crosses the x-axis. Okay, so keep that in mind as we keep moving through this idea. Okay, now, suppose I was to solve this equation. The first thing I would do is add the 15 to the other side. So we have 2x squared minus 11x plus 15 equals 0. Okay? This does not have a GCF. This is the one where we're going to use our little double magic trick here. We're going to take the 2 and multiply it times the 15, and that gives me x squared minus 11x plus 30 equals 0. And then we're going to factor. We got the x and the x. And I need two factors of 30 that add up to 11. That would have to be a 6 and a 5. Both of them have to be negative so that they add up to -11x. Now I hope this doesn't do, because I'm running out of room on this page, I need to put the 2's back in, just like we talked about in class. So I'm going to put the 2 back in front of both of those, just for a moment. And I notice in the very first one that it has a GCF of 2 that I can pull out, and I'm going to throw that away. And I'm left with x minus 3 when I pull the 2 out. But the other one doesn't have any GCF, so I'm going to leave it alone. So I have successfully factored this. So either x minus 3 is 0 or 2x minus 5 equals 0. And now I need to use my algebraic skills to find the possible values of x. Well, if you add the 3 to the other side, x could be 3. Or if you add the 5, right, and I'll get rid of that, 2x is equal to 5. Divide out the 2, and we will get an x value of 2.5. 2.5. Those are the two solutions to the equation. X equals 3 or x equals 2.5. Now, once again, I'm going to take you over to the parabola and show you the connection between these two things. We have a parabola set equal to 0, so that sounds an awful lot like we're going to be finding the x-intercept, or the zeros of the function. So here's the equation. Here is my graph of that equation. Y equals 2x squared minus 11x plus 15. And I am going to zoom in on that, and I hope that you are starting to see the x-intercepts at 3 and also at 2.5. So it's crossing the x-axis at 3 and 2.5. Okay. My next example. Okay, just to practice some more of these. Solving for x. So I would want to bring over the 6 to x squared plus 4x minus 6. I hope you see a GCF. Sorry, it got a little blurry. Whoops. Okay, there we go. I hope you see that there's a greatest common factor. So that's the first thing I'm going to take out is that greatest common factor. And then we can continue to factor this, breaking it apart. I got x and x. I need factors of 3. Well, there aren't a whole lot of factors of 3, so it's got to be 3 and 1. And their difference has to be 2. Well, that makes sense. 3 and 1 have a difference of 2. So I'm okay there. And we would want a plus 3 and a minus 1. Right? So that 3x and a minus 1 add x add up to 2x, and then 3 minus times -1 gives me -3. So we have successfully factored it. Now we have three things that are being multiplied together, and it equals 0. So the quick question I have for you is this. Do you think 2 could ever be equal to 0? The answer is no. Don't waste your time saying, well, 2 does not equal 0. I already know 2 doesn't equal 0. I don't need this. I need to focus my attention on the parentheses. X plus 3 could be equal to 0, or x minus 1 could be equal to 0. But there's no way 2 is going to be equal to 0, so it's not something I need to think about. And when I solve this, I get x equals negative 3. And when I solve this, I get x equals 1. So those are my two solutions. And just to kind of make sure that it makes sense to you, we have a parabola set equal to 0. That sounds like x-intercepts of a function. Here's that same parabola. I was able to graph that. Y equals 2x squared plus 4x minus 6. And when you zoom in and take a look at the x-intercepts, you see that we have an x-intercept at 1 and an x-intercept at negative 3. So, the idea of factoring these quadratics connects between not only the equation but also the graph. Okay? Next example I have for you. Okay, solve by finding square roots. You don't need to factor this one. Now, the reason I don't need to factor is that the b value equals 0. Now, can we factor this? Yes, we can factor it. I see a GCF of 5. So I guess there's two ways to handle this. I'll start out by doing the square root method because this is what a lot of kids like to do with everything, but it doesn't work out because b is not equal to 0 normally. But in this case, the b value is 0, so I can set the 180 to the other side by adding it, dividing by 5. What do we got there? 36. And then obviously taking a square root. Plus and minus 6. Positive and negative 6. Now the other way I could have handled this was I could have pulled out a 5 and been left with x squared minus 36. Now, I don't know if you remember this from your good old days in Algebra 1, but that's a difference of perfect squares. So you're looking for factors of 36 whose difference is 0, right? Because the middle term is 0. Well, that's not too hard. They'd have to be 6 and negative 6, right? Well, what do you get out of that one? Don't you get negative 6 out of this one? Right? If you set this term equal to 0 and solve for it, and what do you get out of that one? Positive 6. So there they are, the two solutions, 6 and negative 6. So I plotted this one on a graph just so you could take a look at it and make that same connection we were talking about earlier. Y equals 5x squared minus 180. And here's the graph. Notice that it goes all the way down to negative 200. But there we are at 6 and negative 6. Those are my two x-intercepts of the graph. Okay, now, example 3 is a story problem about, it says, let me read it here, smoke jumpers are in free fall. Those are the guys that jump out of the airplanes. Quite honestly, I'm not sure why somebody would want to jump out of the airplane with a cigarette. I'm not sure you're going to be able to smoke it on the way down, but oh, smoke jumpers. They're firefighters. Okay, they're in a free fall from the time they jump out of the plane until they open their parachutes. The function is listed, y equals negative 16t squared plus 1600. That's the free fall. See, they're jumping out of the plane at 1600 feet, and they're falling. How long would they be in free fall if the chute opens at 1,000 feet? So we're talking about using 1,000 for the y value. This is one of those situations where you do not have a b value, right? The b value is 0. Therefore, I don't need to factor this. I need to start moving things to the other side. So if we subtract the 1,600 to the other side, that gives me negative 600 equals negative 16t squared. Boy, I'm really running out of room here. Divide by negative 16. Divide by negative 16. So t squared is equal to 37.5. But that's still not equal to t, so I have to take the square root. Now, why in the world? I know. We are supposed to get a plus and a minus 6.1. Why in the world does the negative not make any sense for the application we're talking about? Because negative 6.1 seconds would be before you jumped out of the plane. So it doesn't make any sense in this situation. So the only answer is 6.1 seconds. Okay? It's not negative. Now, just because I didn't want to be really gross in the last example, we might also ask you if the object, so let's say we dropped an object out of an airplane at 1,600 feet and it was falling, how long would it take to hit the ground? I mean, obviously I didn't want to talk about smoke jumpers hitting the ground because that's not really nice. So let's just think about an object falling and when will it hit the ground. What do we use for the ground level? What's the height? What are we going to plug in here for y? I hope you all know that the ground level would be a height of 0. So 0 equals negative 16t squared plus 1,600. Now we need to start solving this. One thing you could do is you could add this term to the other side. 16t squared equals 1,600. Then you don't have to deal with any negatives, but it's totally up to you. So we could divide by 16, divide by 16, that gives me t squared equals 100. And I take the square root, and I find out that it takes 10 seconds for that object to hit the ground. So if you've got a question that's dealing with time and an object hitting the ground, make sure you use 0 for the value of the ground level. See you in class.